Welcome, everybody, to this part of the ESI Live presentation. And I have the privilege of having a conversation today with Max Sikorski from GM. So at this time, what I'd like to do is I'm just going to give Max an opportunity to introduce himself, what he does with ICI Do, and why he's speaking to you here today as part of ESI Live.
Sure.
Over to you, Max.
Thanks, Eric. So my name is Max Sikorski. For some of you have met me before, but my title is I'm a virtual reality leader at General Motors. And what that entails is running a virtual reality lab. So my lab focuses on the execution side of virtual reality at GM. So specifically within the manufacturing space, we're building up vehicles using ICI Do as our primary tool and trying to find as many issues as possible as early in the process as possible. So I've been at GM for about 3 years now, just had my 3-year anniversary actually. And over that time, we've really built up our capabilities, built up our team, built up our facilities to be able to accommodate all these different kinds of virtual builds we're doing with ICI Do.
Awesome, thank you. So you brought up a very good point, right? That the journey of using these digital tools, virtual reality tools like ICI Do is kind of a new thing in industry. And just for those of our audience who are joining us, who are maybe thinking about like, well, how did we do this before? Can you give us some insight onto before digital transformation and before tools like ICI Do? How did people achieve what you're trying to do now with virtuality?
Yep. So it's no big secret. We used to just build cars, and we build a lot of prototype vehicles is how we did. For the history of time, history of vehicles until now, we built a lot of prototypes to figure out what was wrong. And so if you think about it, there's on any given vehicle, there's tons of different configurations, tons of different components, tons of different possible variation of things that can go wrong. So you have to build a lot of prototypes to try and catch as much of that as possible. And that goes for manufacturing side, so figuring out the order you have to build it in, but also goes for the service side as well. So you have to take those vehicles you built, those however many prototypes, and now you got to take them apart and make sure the vehicle is serviceable as well. And the catch-22 of that for all engineering, right, is once you get to the point where you're ordering prototypes and building prototypes, things start to get real, and that means they get real expensive. So the hope is by using this kind of technology is that we start to drive that, what we say is to the left, right? Finding things earlier without real prototypes. But yeah, traditionally we would just build out an entire vehicle as many times as we could, as many times as we could afford, and try and find as many issues as possible to build as good of a vehicle as possible.
Awesome. Now, one of the conversations that I've had with many of our customers regarding this transformation from before using tools like ICI Do and they're building physical prototypes quite often is that I sometimes talk to my customers and like, Eric, using ICI Do today is not going to take away a physical prototype. The physical prototypes went away like several years ago for us, and we've been using different tools to try to address these gaps. But even before, even when we did start eliminating these physical prototypes and we lacked what ICI Do and VR is letting us do, there were still issues that sometimes might creep into production that just went unforeseen because we didn't build the right number of physical prototypes, right?
Yeah.
So when we think about like this idea of designing for assembly and designing for service, now that we've transitioned into using virtual reality and these digital engineering tools, how is that shifting? How is that changing the way that we're doing this vehicle development? And how is that progressing and advancing our goals for digital transformation?
Yeah, and you hit on something really key there, that sometimes it's a push and sometimes it's a pull. So the industry decides how they want us to do things or how many prototypes we can build, right? So sometimes you get a new technology, like say ICI Do, that allows you to build less prototypes, or sometimes you are building less prototypes, you have to find a new technology. And this happened in CAD when CAD became a thing. This happened in automatic path planning when that became a thing. So as new technologies come around, we're able to sort of pull more prototypes out of the process, but it's not just doing less prototypes, because if you could do the exact same virtual build at the exact same time as a prototype, well, you're just doing the same process virtually, which means you're not gaining anything, right? You're just doing it for cheaper. Where the real development, the real change that these kind of tools bring is driving issues to the left. So I can, for example, I can identify an issue X number of months earlier than I could have identified it before. And that means I get to iterate X number of more times before ever having it actually land on one of those real vehicles. Because that's the other thing you mentioned is, yes, there's a reduction in prototypes across the industry, not just us, but there's no one that's gone fully virtual yet that I know of. And so we are going to build something for real at some point. So the goal is just to catch as much as we can as early as possible. And this is something we've seen a ton of benefit from, specifically from ICI Do, where with your traditional automatic path planning tools, your traditional CAD tools, we use the phrase, they give you what's possible, but not necessarily what's feasible. So if, say, I'm installing an IP or a seat or any kind of big old part on a car, right? The automatic path planning tool might tell you, hey, that's possible if you do 16 perfect motions every single time. But the operator on the line building the vehicle, they only have 45 seconds to do that install. So the chances of them getting all those motions perfect every time is pretty low. So it's not just that it's possible, we got to make sure it's feasible. And that's where bringing in tools like virtual reality and ICI Do became super valuable for us, because we could have those same operators that build vehicles wear the VR headsets, and then they can do the build as though it's a real vehicle many, many, many months before it ever exists for real. So they can give actual feedback on whether it's feasible to build it, not just possible to build it. And that's been super valuable for our entire engineering team, because engineers, they work on their component. It's just the nature of the beast, right? No engineer works on the whole vehicle. So you end up with these boxes basically where it works in their box, but then you got to think, well, that box is in the middle of the vehicle, and now you have to get that part to the middle of the vehicle. And can a human even do that? The machine says it's technically possible to get that part there, but can a human do it? So it's a really big part of what we look for as we do our builds. And it's probably one of the biggest benefits we've seen, besides, of course, the reduction in prototypes. And I would say some of it's a push and some of it's a pull, like I mentioned earlier. We can do less prototypes because of our virtual tools, but we were also doing less prototypes because of market demands. So all of that ties into how we're generating benefits from using tools like ICI Do.
Awesome. Right. And a couple of things that I really loved about your answer there is, it's not only that something is possible, that something should be practical for a person to do and reasonable for a person to do. So there's a huge difference, right? If we go back, and everybody will take a look at what we're doing for assembly path planning with ICI Do, and they'll say, our other tools have that. And those other tools will compute for you that there is a path. A path exists. You get a green light. You get a picture of that path in space. But then you find out that it is this, this perfect Tetrising of the piece into position. And it's not always practical that a human being might be comfortable doing that, or maybe even sometimes it comes down to whether I do it or you do it. And that also reminds me of that it's not just that we've done away with a physical prototype and we've exchanged a physical prototype test for now a virtual prototype test. But now it sounds like you're even saying we get to look at more things. We get to look at more scenarios that we weren't necessarily discretely looking at. Or if we roll the clock back far enough into that physical piloting and that physical prototyping, that sometimes we didn't even know we were looking for something. Like when something is just too heavy to pick up or too awkward to pick up and you're doing a physical build, somebody picks it up and tries to carry it into a physical build in the pilot plant, and they go, oh, this is just unreasonable. I would never do this. And then the pilot build's done, and somebody goes, yeah, logistics is going to have to shift the rack. But that didn't become a checkpoint in the checklist that somebody was using in digital engineering before, don't forget to check whether or not Max or Eric find it reasonable to walk with this piece. Right? So one way it sounds like we're looking at more things and we're
Yeah.
looking at them more deeply than we could have with previous digital tools.
Yeah, and that's a really valuable thing with all digital tools, but specifically this one is you can only build so many prototypes. You only have so much money, you only have so much time. But we can get more time by going earlier in the process. And also, it takes a certain number of weeks to get a prototype part, right? Be it a 3D print, be it a real part. It takes time to get those. But we can get our new math into ICI Do in minutes, hours, and do as many iterations as we want because there's no cost limitation to switching out pixels or just switching out math components. So I think it's safe to say that we've done single components with like 10, 15, 16 iterations of a single component. Where if you were trying to prototype that in the traditional style, right, you might get 1, 2, 3 iterations just because you're limited by budget, you're limited by time, but there's none of those limitations in the virtual world. And that also ties into the scale we can do, right? I cannot build one of our plants and do a practice plant, right? It's not financially logical to do that. But in a virtual world, I have as much space as I want. So I can put in a full digital model of a plant and start playing around with things because you're definitely not going to do that at a real plant because plants have to make vehicles to make money. So you're not messing with things on the fly. But in a virtual world, there's no risk, right? There's no limitation. So you can just, oh, this rack might be better over here. These too many parts in this station. Maybe we put a couple in this station and not that station. That kind of stuff can be sorted out in a fully virtual environment. But by bringing it into VR, the next step, then you bring in not just the experts in the design, but the experts and the people who are going to build it, the people who have to do this every day. And they're saying, well, in my experience, those two bolts are going to be a problem to get to. The torque gun kind of it's a little funky, doesn't really fit in that position, and things like that you can find in VR with this great feedback from our operators.
That's amazing, right? And I took an opportunity. I was putting on screen here your particular lab that you've just updated, and this is in the parts production facility, right?
Correct.
Former parts production facility in Warren. And I imagine at one point this room was probably filled with pre-production models made by metal model makers, cars in various states of tool down and tear down, and maybe even like pilot assembly cells, pilot service cells. And in that space now, which is a very enviable space, I think some of our customers are probably looking at that video going, why doesn't my lab look that new and fresh? But now inside of that VR lab, you technically have enough room for an infinite number of possibilities, and not just the way that you're planning on building it here. And if we're building it here in North America, is it going to be stood up in Latin America? Is it going to be stood up someplace else globally? Greenfield, brownfield differences exist, and now you'll be able to look at even more of those scenarios. And so that's an infinitely large space. It's kind of like the TARDIS. I always like to call our VR rooms because they're bigger on the inside.
Yeah, and actually you touched on something really interesting there. Well, first off, we actually this used to be a headliner room where we would spray glue on headliners. So it used to be full of glue fumes. So I think this is an improvement. But the reason it's here, the reason it's in an industrial environment, and this is really important in my mind, is that this is where all the expertise is, right? This is where instead of telling the guys from the prototype shop to come to a VR lab in some nondescript office building, right? We just built the VR lab where they build the vehicles. And that means we have all the expertise on hand. It's like, man, I've never seen this before. I bet you Johnny Worker, who's been in this place for 30 years, has seen it before. I can go ask him what's going on with this. And we get certain people who even are really excited about it. They want to be back here. So they wear the headsets and they'll jump in there and they'll point stuff out and they'll tell us we're stupid and our designs are bad. But that's what we want early in the process. We want that sort of tribal knowledge that's existed for decades and decades in the auto industry. We don't want to lose that by being like, oh, we only need people who are computer whizzes and gamers. We want to have all that expertise with us as we move into a virtual future, so that we can get all that knowledge into our vehicles still. Because if we go, it's not worth it if we start building vehicles all virtually, but we lose all the century of experience that's behind us.
That's awesome. Thank you. And that leads us right to the next question I'd like to ask you is that, so, you know, I don't think we're done growing. I think the industry and enterprise has a lot of opportunity in how we harness VR and virtuality and extended reality into our engineering workflows. So thinking about that road ahead with ICI Do, how far along do you feel you are in your journey, if you can speak to that? And what do you see next for doing this virtual build or virtual maintenance kind of validation?
Yeah, what I would say, the terminology I would use is that we are industrialized with our VR processes, where we're part of our engineering process. Every vehicle is touched by us, and we look at everything virtually. That was a big step we made a few years back, and it's been really beneficial, or really just satisfying, right? Because a lot of this stuff gets stuck in a pilot purgatory, as we like to call it, where, oh, we're trying it, it's cool, you can try it on this, you can try it on that, but it's not part of the engineering process. No one's forced to do it, because you're always going to have doubters, right? People who push back against you. So putting it as part of the process where people have to come here, that's the way you win them over, because a lot of people just wouldn't do it if they didn't have the choice, or they didn't have if it wasn't built into the GVDP. So I would say we're pretty far along our journey. Obviously, I can't give you specific numbers or anything like that, but we're at the industrialization phase. So we've rolled out in, obviously, my lab, but we also are rolling out to our various plants, utilizing the collaboration tool within ICI Do. Because while we have a lot of knowledge at the pre-production operations area within PPO, there's also a lot of knowledge at the plants that we want access to as well. So instead of them just watching our Teams calls as we started out, now they can drop in using that ICI Do Collaborate tool and work with us in our virtual environment, point things out. Once again, tell the engineers their designs are bad. It's their favorite thing in the world. If they can tell the engineers their designs are bad, they're the happiest people in the world. So it's really good fun, and we've won over a lot of doubters is the other thing. Where I'd say we're past the point where people are going, what's the point of this? They might still be frustrated by the technology. They might still be frustrated by what we can't do, but no one's saying it's pointless. No one's saying, why are we even doing this? It's too hard. That's all behind us. And now we're at the point where people are asking for more, really. It's what technology is coming next? What can I get? What can I find a couple % more issues here? Can you do this crazy thing in virtual? That's where we're at now, which I'm really happy about, because that opens a lot more doors for us for what's coming next. So what's next for us is obviously the continuation of our main work, but it's really, now we're at the exploratory phase again. We've almost come full circle. We've made the VR build events boring, so people want to see what's next. And that's, be it through ICI Do, the new features coming out with Flexibles, Collaborate. The 2D Flex is a big one that we're really excited about, but also how do we make our processes better? The scripting stuff that's coming in the near future in ICI Do is super valuable to us in making our process better, so we can do more of these. Because now, see, that's the other problem, is that now that people don't think it's goofy and odd, now they want to do them every second of every day, which is great business for us, but also that means we have to get better at making them. And then I would say, lastly, it's all about just what's the next technology coming, right? What's the next headset? Can we get good gloves? All that good stuff, which I know is a pain point for every VR dude or lady around this really small industry, is can we get the next piece of technology that gets us just a little bit better? And can we get it integrated into ICI Do?
Awesome, right? Because I heard the key parts that for the out of your answer for me, if I can stop tripping over my tongue, is the fact that what you see in the future is getting more people involved, right, through that use of global collaboration, remote collaboration, and the inbuilt capability to collaborate with ICI Do. And then also make sure that the people, when they are connected, they're actually experiencing things more realistic. They're getting more engaged, they're getting more involved, because while the gloves are a neat novelty item, they should be making that assembly worker that you're pulling from your industrial site, or if you're connecting with one of your global colleagues, one of your global peers, they're grabbing somebody off their assembly line, and they should be able to put them in VR and have them experience it as if they got on a plane and flew to your site and were walking through the piloting facilities. And it should be that transparent. And hopefully we are able to deliver that technology to people that create that transparent connection. But that doesn't matter unless we're part of your business process. And so it's great to hear that as we've integrated, as you've industrialized ICI Do to your business processes, it's become standard operating procedure. And now is a good time to deliver more technology that makes it more immersive, more involved, so that we can continue to do that good work and that good delivery.
Yeah, you've made it when people are bored and they're like, we've seen this before. That's what I would
there,
say,
done that, right?
Exactly. They want to see what's next. They want to see the new toys.
All right. Well, I want to thank you very much for taking the time to join me on this call today, Max, and very much appreciate everything that I've learned from you in this call and also in our previous conversations. I just wanted to put a little plug up here for the last time I saw you face to face was probably at the Boeing wide body assembly plant. So those are two pictures of us together at Boeing in Seattle.
I'm wearing the same shirt.
User group.
Yeah, that's great.
Yeah, you're there.
Yep, in the red. Same shirt I'm wearing today.
Absolutely. So again, thank you very much, and we look forward to continuing this conversation. And I again want to invite everybody who is participating, and if you are an ICI Do subscriber, Max is one of the steering team members of the North American User Group, and we quite often are learning from and benefiting from his experience and his peers, his colleague George Gu and the rest of the team at GM, for learning how they're getting through this idea of performing virtual build or virtual service within ICI Do. So thank you very much for your time today, Max.
Yep, thanks for having me.